Hello, this is Keith Graham from Codasip. I would like to review Assignment 2, Checkpoint 1. Now, in this checkpoint, you're going to be writing a very simple C program. We're going to declare some variables, initialize them, do a for loop to create a result, and then you're going to actually print them to the console window using a printf routine or function call. Now, before we go into Codasip Studio, I'd like to point out a couple things. The type of C language that is supported in Codasip C or Codasip Studio does not support declaring a variable within a for loop. So you won't be able to, for example, declare uint32t in your for loop for the I element. You're going to have to actually declare your variable outside the for loop, and then you can initialize it within the for loop. Now let's take a look at Codasip Studio and exactly how you would actually debug or run your C program. Early in the assignment, you should have imported three projects. One is the assembly abstraction, which will be used for checkpoint 2, then the C abstraction, which you'll be using for this checkpoint 1, and the IA RISC32I. You might have had this already imported from assignment 1. If you did, you do not have to re-import it for assignment 2. Now, in the C abstraction, it's just a template. The template is empty for you, but I did type in a simple printf to show you that we can use a printf in Codasip Studio. But to be able to have the printf, we need to include two libraries: the standard IO and the string libraries. By including those string libraries, it's going to affect on how we configure the compiler. Now we're going to go to the workflow perspective. And since I'm using my IA RISC32 model from assignment 1, it's already generated, so I don't have to regenerate it now. But I do have to assign the SDK to my C program. Now I'm going to wait for the assignment to complete. And you can see the assignment is complete by looking at the notification on the lower right-hand corner. Now with that complete, I'm going to configure my compiler. And for the assembler, you selected no startup. But for the C program, we require the startup because the startup file actually sets up the stack pointer, which is required by the C compiler. Now the first thing we're going to do in these extra flags is we need to tell the linker where to find those libraries. So I'm going to actually just copy and paste them right from the assignment. This will help me reduce my errors of having a typo error. And then there's some extra flags that we also have to set for the linker. And this is setting up the size of the heap memory. And we're setting it up to 2000 hex bytes. The heap memory is very important because that retains data from one function call to another function call. And printf requires heap memory. So we're just telling the linker in the C compiler to allocate 2000 hex bytes for this program. Now with that all completed for the compiler configuration, I'm going to hit save. I know my compiler configuration has been saved because the window closed. Now I'm going to go to launch debug compile configuration. It's always best practice to have it stop when I enter the debugger. So stop at startup. Now, previously we were selecting after in instructions for assembly program, but we really want to stop as soon as we enter main. So I'm going to click on at function or address, and then I'm going to type in main, save. And just like C compiler, the file is closed, so I know my debug configurations have been saved. Now I'm going to launch the debugger. So I'm in the debugger now, and before I actually execute the debugger, I'm going to put a breakpoint at my printf, and I'm going to resume to my breakpoint, and you can see that I'm about ready to do the printf. I'm going to resume, which will execute the printf function call, then actually exit my routine because I don't have anything else after my printf. Now you can actually see at the lower part of the debug console, you can actually see my printf right here highlighted in blue while using the dark Thea format. Now, I just showed you how to actually set the linkers up for the C compiler to use standard I/O and string libraries. But I also want to show you one more thing before I end this video. So another way you can actually execute your code is just running it, which does not use the debugger. So we'll just actually execute your code as written. And since I have a printf, it will actually print it out to the console window. And you can see right here, it just printed out the result. So you can actually get the results of your C program through running the program with a printf statement or viewing it through the debug console. Hopefully this video is helpful. If you like it, please subscribe to this channel so you'll be notified when additional videos are added. Thank you very much and have a great day.